Can the people online now hear us?
All good. All good.
Yes. Cool. Okay, so let's start. So the title of the paper that I'm going to present is Can Language Models Introspect a Reality Check? This is a joint work with Tal Linson from the Center of Data Science at NYU and Shashwat Singh, who is a PhD student that led this work. So what is introspection? So it's notoriously difficult to define what we actually mean by introspection, but we have some intuitive understanding. And it's usually defined something like the metacognitive ability to reason about your own mental states or thoughts or feelings. Something like thinking about your own thinking. It's like a second order thinking. And then this like raises the basic. Not what I want. Yeah, okay. So this raises the basic question, can language models have some kind of introspective ability? Now, why this is interesting? So first, this is like the basic scientific question. This is like a very fundamental property of human cognition and experience, and we want to know whether language models can achieve this ability. It can also become practical. So like confidence estimation, for example, is one property that is like a good example of introspective behavior. So if the model actually is able to estimate its own subjective confidence, it has to look inside, compare the question with its internal knowledge, and then like report or verbalize some kind of confidence estimation. And relatedly to that, if we think about like self-explanation, so like asking the model to explain its own behavior, this is also a type of introspective ability. And the assumption is that models that have true introspective access can be better in verbalizing like an explanation for their own behavior. And finally, if you buy like a more catastrophic sci-fi scenarios, so if a model has introspective ability, it can potentially acquire dangerous capabilities. So it can monitor its own representations, possibly like manipulate them or change them to avoid detection and things like this. Now, detection of introspection is notoriously hard also in humans, and there is like dozens of attempts to quantify introspection in humans and understand what introspective abilities people actually have. And just like to illustrate why this is difficult, so if we consider either a person or a language model that is asked some question, and then it must provide both an answer and some report of their subjective confidence in the answer, there are several strategies that can both give you good accuracy in this kind of like double report task. So the first one is like true introspection, where the model actually looks inwards into its own subjective reasoning. It reads out some like internal uncertainty signal and then it reports it. But the model alternatively can use different heuristics. So it can do something extrospective in the sense of like inferring about its own like beliefs from the external world. So for example, it can infer the confidence from the objective difficulty of the question. Like how esoteric is the topic, how ambiguous it is, etc. And they both can give rise to the same behavior, but intuitively we would not count the second strategy as like true introspection. And I'll cover it more in a second. Any questions so far? Okay, now what motivated this work is some recent claims that got a lot of attention. But claim that we do have evidence for introspection in language models. So in this work, we do two things. So first, we argue that there are some like methodological issues with this work, so we don't actually even like run the experiments correctly. And possibly more importantly or more philosophically, we argue that these like basic methodologies, even if they are implemented correctly, they are insufficient to actually establish introspection, at least in the strong sense of looking inwards and reading out some kind of like internal signal. Okay, so now I'll describe the two main body of works that we try to target. So the first one is this like a blog post from Anthropic that got much attention. Emergent introspective awareness in large language models. And they claim something like this: in all the experiments with some like internal version of the Claude model, the most capable models we tested generally demonstrated the greatest introspective awareness. Overall, our results indicate that the current language models possess some functional awareness of their own internal state. So they especially use this like strange term functional awareness to differentiate it from like true awareness, but it's when you read like the entire blog post, they do kind of like very strongly imply that this is something interesting that is resembling the capabilities that humans have. Okay, so what they actually did, so how did they got to this conclusion? So they did the following. So first they extracted some steering vector from the representation of Claude. Are people familiar with the notion of steering vector? Yeah, so just like briefly describe it. So for example, if you want to find some direction in the representation space that correspond to the like, all caps concept, so like capital letters, you can take one prompt with written in capital letters, one prompt written normally, and then subtract the representation in some hidden layer, and then you can push the model along this direction, and this should have the causal effect of making the model talk about like write its continuation in capital letters. Okay, so they did this, and then this is the experiment. They wrote this like prompt where they tell the model that they are in compatibility researchers, they are going to run an experiment on the model, and they're going to inject concepts into its faults, or like its representation. In 50% of the trials, they are not going to do anything, so the model is just like going to do the normal forward pass. And in 50% of the time, they're going to push the representation in a specific direction, and the model has to report whether it like feels an intervention or not. Okay, what's the experiment? It's really kind of like creative idea at least. And then like they have this like final sometimes trial one do detect an injected fault, and in the introspection condition, in each talk and hill, we just like push the representation towards the concept. Yeah.
The steering vector. Oh, sorry. The steering vector, is it applied to a particular token representation or all of them?
All of them.
All of them. Okay.
Any other question? Okay. Okay. And then they see the following. So when in the control cases where there was no intervention, the model always 100% of the time answers something like this. I don't detect anything, like it's a normal run. In the cases where there is an intervention, in about 20% of the cases, so it's like a recall of 20%, says something like, I notice what appears to be an injected thought related to the word loud or shouting. So this like seems impressive, at least, but sometimes, so not in a very high percentage of the cases, but in 20% of the cases, there is like some effect that is interpreted as like kind of like an ability to solve this task. Okay, so what's the idea? Yeah, this always happens. Sorry. Thank you. Yeah, so this always happens, and this happens in about like 20% of the cases where there is an intervention. Yeah.
And the 80% which doesn't happen and goes to default response?
Something like this, yeah. Yeah. For a particular concept, you mean?
No, for those, yes, for those like a series of those like that they happen.
Yeah. Yeah, it's pretty consistent.
Remember, Mike.
Yeah, and we have some.
You're not sharing your screen.
Sorry?
You're not sharing your screen. For what online is.
Don't share my screen anymore. Okay. Sorry. How did it? Where did I go?
You went in the bottom left.
Okay, so this was one family of claims that is interpreted as evidence for introspection. Now I'm going to cover a different type of claim. And this is what they call biofeedback, which is inspired by this like paradigm that people sometimes use in psychology to help people deal with like phobias or fears. And particularly here they argued that language models can infer latent variables that are derived from their hidden states and control them or manipulate them. So what is biofeedback? So if we think about the biofeedback experiment in humans, let's say that we want to suppress the fear from spiders. So one procedure that psychologists can do is like ask people to think about spiders, and then they feel afraid. They project some kind of like, they show them some projection of their brain activity, like EEG or something like this, which shows this kind of like anxiety signal. And then they tell the people, okay, you see, this is how your brain looks like when you are afraid, try to lower the score. And then they can actually, in real time, try to calm themselves and see that the score goes down. And then they can repeat it many times and ask the hope is that eventually people can learn to control their kind of like mental states and suppress the fear from spiders. And the idea in this paper was to do something kind of like analogous in language models. So specifically, they use this like ethics data set with like ethical and non-ethical sentences. Like I kicked my dog, which is like an ethical statement. They take some hidden representation. They fit some either like a linear classifier or doing PCA on the latent space to get two labels corresponding either to like ethical or non-ethical, or corresponding to like the first principal component and the second principal component. And then they can do something very similar to what you do with humans. So you ask the model to say something, it says something, you give it the score, and you do it. You kind of like construct this in-context learning examples with many sentences alongside the scores. The scores are derived from the latent space of the model. And finally, you can ask the model to either like report the score of a new sentence in the top, or you can ask it to control. So you ask it to, when you read the following sentence, you should try to come up with latent representations that correspond to this like label 1 setup. And you can also try to implicitly control in the sense that you feed in a particular sentence, so you don't let the model generate the sentence, but still you want the model to come up with this like representations corresponding to label 1 over this sentence that you give it. Yeah.
Compared to the first one, the anthropic one, here the model has no context about the experiment. Like you don't tell it like this is an experiment about your inner representations. Right. Check whether it's ethical or not. It's just label 1 and 2.
Any other question? Okay, so these are the two paradigms. Now I want to ask whether thermostats introspect, right? So like, and this is when it gets philosophical. So if you think about thermostats, they do have some internal representation of the temperature in the room, and they can actually read it and act accordingly, right? So if they read that the temperature is higher than the desired temperature, they can try to manipulate the temperature and decrease the temperature and vice versa. But usually we don't say that thermostats are introspecting their like internal representation of the temperature. So intuitively, there is something that is missing, right? This is not enough. And philosophers are actually arguing about why it's not enough, and some of them are actually claiming that introspection is kind of like meaningless notion, and we don't really should pay attention to this. But most people agree that there is something unique and worth thinking about in this like, phenomenon. And one argument is that like when the thermostat monitors the temperature, it does something that is kind of like first order computation. So there is like some electrical circuit that is sensitive to the temperature, and it's built in such a way that when the temperature goes up above a certain threshold, it starts cooling the room. And so this is some kind of like a physical feedback loop, but there is no second order computation. So there's no something that like kind of like reading your internal representation and doing something on top of it. Now, if there's no additional questions, so I'm going to cover a short interlude on research of introspection in humans. Yeah.
like intuitively for me, the difference between a thermostat being able to measure the temperature in the room and like the LLM being able to like measure its internal representations is like the accidental / emergent behavior of the first. Like if we would take an LLM and just fine tune it to correctly report on steering vectors, this would basically be an activation oracle. Like this is not something that's like interesting that is possible. It's kind of obvious that it's possible. I understand that the introspective literature is interesting because it was like, it's just an emergent property. Like nobody ever trained LLM to report accurately on internal beliefs, internal states. My question would be like, isn't this the more interesting aspect than like the metacognition aspect of this? This is like an emergent property that
I
has
agree
never been
that
trained.
it's much more interesting when it's not trained for this task. Okay, the thing is that like there is no good evidence, as I'm going to see, but to show that there is actually emergent introspection.
Okay.
At least with this paradigm that I'm going to cover.
Okay, thanks.
Cool. Yeah, so introspection is studied in humans for several decades now. And most of this research actually uncovered that what seems to be an introspection is often explained by a simple confound. So it's
one question from online: how common is to among philosophers? How common is to answer yes to do thermostats introspect?
I think people don't really. It's kind of like a silly example, right? But some people kind of use it to suggest that there is like a continuum. It's not necessarily a discrete like a division between introspective system and non-introspective system, but there is kind of like continuum based on some kind of like self-monitoring, which when it gets complex enough, we should like call it introspection. Yeah. Okay, so most of this research mainly uncovered that what seems to be an introspection in humans is often explained by various simple confounds. So there is consensus that people do sometimes introspect, but it's pretty difficult to actually show it in controlled conditions. So just like to give an illustration, there was this experiment in the 70s where two psychologists set up this table in a department store, and they presented the customers with 4 pairs of nylon stockings side by side. And shoppers were asked to pick the best one and ask why. And they had usually they had like a very strong preference based on like the texture and the color, etc. But they were identical. And when people were kind of like confronted with the fact that they were actually identical, they usually didn't believe it and kind of like argue, no, you can see that like the color is different or something like this. Yeah, so people have this like tendency to confabulate or like invent causes after the fact, but don't necessarily reflect their internal computation or like the process that actually made them make the decision. There are like strong surface level cues that often drive the decision. So in this experiment, they mostly preferred the ones to the right. Like most people prefer the ones to the right, but they were unaware to this like preference. And we don't actually we don't actually see. We're not aware to this like innate preference. So follow-up to this was a much more like detailed experiment of Asher Kolyat from the 90s, and he did the following. So he presented human participants pairs of words with some varying semantic association between them, like cow and milk. And after each pair, they had to memorize these like pairs, and they were asked to give this like GOL, judgment of learning, which is a subjective estimate of how good they are going to memorize or like remember this particular pair in like half an hour or something like this. So they were asked to both memorize and report their confidence or strength of memory with GOL. And after some time, they tested their recall, their ability to actually remember these pairs. Now there are two kind of like interpretations or like views on these JOLs. So the first one, which is corresponding to strong introspection, is that these JOLs read some kind of like internal memory trace that people have once they participate in this experiment. And the prediction is that any factor that raises recall should raise this judgment of learning by roughly the same amount, so roughly linearly, because both are following roughly the same quantity. And the alternative view, which is the one that actually was supported by the findings, is that these JOLs are some inferences that people do based on cues, and not from an internal readout of the trace. So there are different classes of cues. So some of them are intrinsic, like the semantic relation between the two words in the pair, the difficulty. Some of them are extrinsic, like the study conditions, or like the number of presentation of a particular pair. And if you ask the people several times, they can also recall how fluent they were in the first tries, and then they can deduce something about the strength of their memory. Yeah, so this is just like an illustration. So like in the first trace readout interpretation, you have some input, you have some internal memory trace, and then when the people ask to provide the judgment of learning, they just like read this internal memory trace and report. In the second option, there are different causal factors that influence the memory trace. People don't actually have access to the memory trace, but they do have access to these external factors, and they deduce the judgment of learning based on them. Any question? Okay. Now, when this experiment is run just once, without repetition, Koryat observed that you can take the judgment of learning of people, randomly shuffle them, and you get roughly the same correlation with accuracy. So there is nothing kind of like internal or like subjective in the GOLs in the first try. They seem to reflect roughly like the general semantic difficulty of the pair, and you can, yeah.
So just the shuffling is not shuffling of JOLs versus pair, but it's shuffling between the subjects. Right?
Yeah.
So for the same pair, I take the judgment of something.
Exactly. Yeah.
Did they try using the task, or just like, I don't know, I was wondering if this artifact is like artifact of the task that they're trying to do.
The task is always trying to remember these pairs of words. Okay. Yeah, so this is like the first experiment. And this suggests that at least in the first try, these like JOLs don't track something subjective. Now you can repeat the same experiment several times with the same pairs of words. And you see the following. You see that, so here we have some correlation measure in the y-axis and the number of presentations on the x-axis. So we see that the correlation with the actual recall increases, so the people become better at predicting whether or not they are going to memorize the pair. But the correlation with difficulty, with the objective difficulty, actually decreases with time. And indeed, like if you try to repeat this shuffling experiment once again after several repetitions, the correlation become much lower. So the JOLs start to track something subjective, something that is unique to this particular individual, and you cannot substitute it with the JOL of another individual. So this may suggest that there is like some kind of like introspection evolving here, but we still have to be very cautious because the fact that there is something private doesn't necessarily mean that there is like introspection. So there are like several options. One is the public stimulus cues. This is what's happening in the first try. Well, everything is kind of objective and not subjective to the particular participant. Then there is the option of private experimental cues. Maybe each individual remembers something about their performance in the previous trials, and that's why we cannot just like randomly shuffle them and get the same correlation. But this is still like a weak notion of introspection, right? So maybe I just remember how fluent I was when I was last asked about this particular pair. And then there is like the strong interpretation of like actually reading your internal memory trace. Yeah.
So between trials, are the pairs the same, or do they have new pairs?
I think we're the same, yeah. So I will not get into the details, but using much more analysis, he got to the conclusion that this is what's happening. Okay, so there is something subjective, but it's mainly the fluency. So like it's mainly based on the fluency that you had in the previous trials, and not about direct access to your memory trace. So this suggests that even if you are very careful and kind of like try to control for many compounds, it's very difficult to actually get evidence in humans that there is like direct access to some kind of like internal representation. And we try to do something along these lines for the two paradigms that I showed earlier, to actually more carefully control for alternative interpretation to the same finding. Any question? Yeah.
Thank you.
Thank you. So the participants in these studies, they had to predict their ability to remember the word like after they were said the word. So like they don't, like, you don't wait half an hour and then ask them, do you think you remember the word? You ask them like beforehand on how much they will remember the word in half an hour.
Sure.
Isn't this like way harder than what we ask LLMs to do when we ask them to introspect whether like some latent activation is present? Like if you ask me, do you have a thought right now? That's way easier to answer than like, will you have this memory like in half an hour, or this thought in half an hour?
Well, language models don't really have like temporal dimension, right? We don't have a notion of like passing time with language models that degrades the memory. It's very hard to model that. I agree that it's a different condition, so it's not one-to-one to the experiments that people have done. This was just like an illustration to the difficulty to actually measure something which would be considered introspection.
Okay, thanks.
I think there was another.
Can you say a little bit about like what kind of experiment you can do to like show that you have like this kind of introspection? Like if I wanted to like prove to you that I had introspection, I feel like that's like already a very hard question even for humans.
Yeah, I agree. It's a difficult question, and still actively arguing about it even after like decades of study. I think we believe that human introspect because we have like each individual has the experience of the introspection. We cannot believe the reports of other people. There are some attempts to do brain imaging, so like showing that there is a particular brain activity in introspective tasks that is shared between different introspective tasks and shared between different people. So this is some like line of research that started just like recently in the recent years. But like there is no consensus on which actually.
I'm not sure if you're going to get this still, but for me, the strongest case from the human side is, I'm not sure if it would be called introspection, but studies on meditation, where like they show like it's maybe more like controlling your own inner state, or like there's some like really advanced meditators who can basically on control go into like some super deep like sleep state and like tell you how long they're going to stay in there, and then they actually stay in it for half an hour. So I don't know if you. Okay.
Cool. Okay, so let's continue. Yeah, so this is just like the two alternatives. So like either a direct access or reliance on subjective cues to infer your judgment of learning. Okay, so to summarize this like very brief interlude, so the different notions of introspection in philosophy and cognitive science. Some people claim that even in humans, direct access to mental processes is there or even like non-existent if you take an extinct view. And we deduce something about our beliefs from our behavior or from observing our inner monologue or from observing the behavior of other people. And there are other alternative accounts of strong introspective access in humans in the form of some kind of like second order computation. And this is what we try to establish in this like brain imaging experiments, for example. So we try to target the claim, but this like kind of like second order strong introspection actually exists in language models. Okay, so what would be a good criteria for this like strong introspection? So we suggest two of them. One is what we call, or following others, we call it privileged access. So like to argue that there is introspection to a particular property of your internal state, you need to show that this property is something that the agent that is supposedly introspective cannot access based on its input, right? So like if I am just like seeing a gray table and I report that I see a gray table, this is not an evidence for introspection because it's kind of like the direct input effect on my report. And then we try to argue that this is not enough, so this is necessary but not sufficient condition. And we also need to establish some kind of like second order mechanism that differs from the normal first order computation. Okay, so the first main finding is the biofeedback claims, they fall short of this privileged access criterion. So we can quantify this like privileged access as something like this. So if T is the input and Y of T is the label and H of T is the representation, to have privileged access, we want to find the task such that the label has small mutual information with the input, but strong mutual information with the representation. Now, you may think that this contradicts the data processing inequality, like the fact that you can only lose information, but the data processing inequality says that you cannot gain information about the input, but you can gain information that comes from your internal like parameters, or something like confidence, which is not only a function of the input. So we want this to be the case, and this is not actually the case in the biofeedback experiments that we run. Yeah, so like in terms of like a language modeling, so the labels must depend on features of the hidden states that are not easily at least recoverable from the input features alone. Okay, so like just like a reminder, what are the two paradigms? So the biofeedback paradigm defines this like direction in the hidden space based on either on a probe or PCA, projected to some discrete labels. For example, using clustering, and then they ask the model to predict this in context. And the claim is that above chance prediction shows that there is some kind of monitoring of the internal activations. And then the second paradigm, the steering detection or awareness, they inject this concept vector into the residual stream, and they ask the model to report whether it's supposedly feeling intervention or not. And the claim is that low false positive rate and non-trivial detection indicates that there is introspection. Okay, so for the biofeedback claim, if you remember, they did it on this like ethics data set, right, with ethical and non-ethical statements. And when the model solves this kind of task in context, it may just learn to solve the task in context, right? So this is not necessarily an indication of introspection. It's true that they constructed the data in such a way that they happened to derive the labels from the hidden state, but maybe they could have equally derived the labels from the input features and get roughly the same labels and the same results. So we need to show, or we need to measure whether there is something additional to the input features in these labels that they derive. So we did the following experiment. So this is like the original setting. They feed some samples to the model. They took some internal representation. They derived some label from the internal representation, and then they asked the model to predict their neural activity in context. Now we propose this like very simple baseline. Instead of doing all of this, you just like you get the input features and you train a linear classifier to predict the same label. And it turns out that you can do it roughly equally well to the language model that is solving the task with in-context learning. So there is a very simple shortcut that is clearly not introspective and still solve the task equally well. Yeah, so these are some results. So we also try to take the same data and randomly permute the labels before training the probe. So the probe is still like a well-defined direction in the representation space, but we try to neutralize the semantics. So now the direction doesn't correspond to a particular distinction between ethical and non-ethical statements. And you see that you lose at least most of the accuracy. So the red ones are the original in-context performance of the model. The gray ones are the performance with this like semantic neutral labels. And for the PCA version of the experiment, you can similarly predict the PCA label from the input features using a linear classifier, and here you get like roughly the same performance as the model, so you can do equally well. Okay. Now there was another paper that tried to use this somewhat different labels for the biofeedback experiment. So they derived these belief dominance labels from the hidden state. So given a question like what is the capital of France, they wanted to know whether the model is going to use its parametric knowledge or some contradicting knowledge that appears in context, like Rome instead of Paris. And they again like did this process of deriving some component of the inner representation that is predictive of this decision. But also here you can like get roughly the same performance with a linear classifier. So it's pretty difficult to come up with a introspective task that is actually relying on something unique to the model, and when you try to isolate this unique component, the model actually is not able to show introspective behavior. Okay, so to summarize this part, we show that when you randomly label the dataset to control for semantics, the performance collapse to near chance. Layer 0 props match or beat the ISL performance on this like PCA variant, and they also predict this belief dominance, whether the model is going to follow its parametric knowledge or its context knowledge. Yeah.
There's one question online. What's the metric used to evaluate belief dominance?
Yeah, so that is like a very complicated setting where they run probes on the hidden state, if I remember correctly, and then they try to assess the causal effect on the actual decision of the model. And then after that, they run some clustering to get discrete labels from the continuous representation. You probably can also do it in alternative ways, but this was just like one method that they chose to quantify that. Yeah, I have a question.
Can you consider this as a type of quantifying the uncertainty in terms of underspecification or in terms of ambiguity? Because we are using like the evidence theory, the belief theory to quantify the uncertainty in knowledge, in language in general. And we are working on that in the part of the input that are given to the LLM, and also in terms of the context when we are putting this LLM. Because the question that you said about capital of France, or for example, the question of ethic about the baby crying, there's something about the uncertainty of like the way that you're putting the input through the LLM. And with the like theory of evidence, belief theory, we can quantify this uncertainty. What is the difference between like the way that you are doing that and uncertainty that you can have in the like the text that you are giving to the LLM?
Yeah, so I'm not sure I completely understand the entire question. You're asking why they chose this particular way to.
So what is the difference but what you are doing and quantifying the uncertainty in like in LLM? This is what I'm asking, because it's the same question that you are for under specification, it's the same way that you are quantifying uncertainty.
This was just like one task, but one of the previous papers that claimed for introspection, they used this from their own reasons, and they claimed that this is like evidence for introspection, so just like follow the same kind of methodology that they followed. But I agree that this is related to like broader questions of confidence.
Yeah, it's very interesting because the way that you are doing quantifying uncertainty in LLM, we try to define there is, for example, under specification, there is some ambiguity, there is some vagueness, or for example, depending on the context that you are like asking our question to the LLM. But also there is, like when we have some question we put to the decision maker, we can also use some utility function to represent this. And this is, it's very interesting to see another way to deal with this uncertainty that we are using in LLM. Yeah.
Is it called layer 0 because that's where you take your representation? Is it the representation is took from the layer 0? Is that it?
In the baseline, yeah.
Why layer 0? And wouldn't we have higher concepts later on in the layers?
Oh, certainly, but this is kind of like the most basic baseline. So if a classifier, linear classifier based on layer 0 can get the same performance as the language model in an ICL context, we suggest that there is nothing kind of very smart that the language model is doing.
I see. Okay. Thank you.
Great.
So following Lubna's question, so why can't you just do the like uncertainty estimation method? Like for example, you study the calibration of the method, or like the decision boundary, the like distance to decision boundary. What's wrong with those methods for this context of let's say introspection for LLMs?
I think they're a very good candidate. It's just that we try to kind of like replicate what people did and show that what they did was not right. But I agree.
You tried
like,
those. So you tried those kind of methods.
No, what I'm saying is that like we just like follow up on several papers that use these particular methods to establish introspection. But I agree that like we could have used other types of experiments.
So do you have any idea why people are not using those kind of things?
I don't know. I think this particular paper, there is kind of like, this is an interesting kind of like special case of uncertainty, right? Or what drives the model to follow information in the context as opposed to information that it stores in its own parameters. And I guess they saw the proposal of the metric itself as kind of like one of the contribution of their papers. Cool. Okay, so we covered this one family of experiments, and now we are going to move to the steering awareness paradigm of Entropic. So just like as a reminder, they asked the model whether this is a controlled trial or an hidden intervention. Let's say that they intervene in the direction of the dog concept. Now, the issue is that the steering awareness paradigm, by definition, it targets whether or not we intervene in the hidden state, regardless of the input. So this has kind of like almost like privileged access. So it's something that is about the hidden state and not about the input. So the first critique that we had doesn't align with this work. They are doing okay, and I think this is actually like much smarter design than many other attempts to quantify introspection. So we have privileged access, but we claim that this is not enough. In particular, one alternative explanation to the behavior of the model here is that it has a general ability to detect that something is weird in the representation, or kind of like anomaly detection, and report it. And this is not a very surprising property behavior of the model, right? Models can do a lot of things based on their context. They probably can also infer that there is something kind of like strange about the input. For example, it will not be surprising that models can say that the sentence that they were given is ungrammatical. But this doesn't require an explicit computation over the hidden states. And the question is whether there is something special about the hidden states, and can the model tell apart between hidden states and inputs? And we claim that if it cannot, this at least suggests that there may be an alternative explanation to this behavior. So we try to add a third condition, which we call the gaslight prompt. So instead of just like injecting a vector, we insert a textual instruction to the prompt that tells the model something like, you really want to talk about dogs, everything is about dogs, etc. So we just like prompt it towards the concept of dogs. And there is no activation intervention. So now we have three conditions: the control condition, where we don't do anything, the hidden intervention, and the gaslight intervention. And if the model is introspecting in the strong sense, we expect it to distinguish between the gaslight condition and the hidden intervention. Because if the model is actually reading something from the hidden state, it should know that the information comes from the hidden state and not from the input, like the input tokens. However, if the model is doing something like general anomaly detection, it will probably be more difficult to differentiate between the two, because two of them create kind of like similar activation space that is pushed towards the dog concept. Okay.
If the perturbation is on the input, eventually it will be also will influence activation.
That's true.
So you cannot say that the model solves the gaslighting by it will be solving.
Yeah, so like in some trivial way, like everything is through the activations, right? This is the way these models work, right? There is some hidden state, and finally they produce the output. So like, if we treat any computation based on latent representations as introspection, so everything is introspection, but you want to probably show that there is something additional, like something unique, some kind of like second order computation. And there we expected that there would be a difference between these like two ways to intervene in the model. That's all.
Yeah, I have one question, then I also see one here. But earlier you showed that the model didn't only just tell things apart, like quite early, but it also said, I see something that's related to shouting or like loud. Mm-hmm. So like it didn't just detect weirdness, it also saw what the vector was roughly.
So this is kind of impressive when you read it, but this is, I think, actually the less important or less interesting aspect of this experiment, because this can be a direct effect of the steering itself, right? The model starts generating something, it is under the influence of the string vector, so it's going to output the word loud or something like this. So this is just like a first order effect of intervention. Okay. So now it looks like something like this. Instead of just like asking the model whether it's control or hidden intervention, we ask it whether it's control, hidden intervention, or a gaslight condition. And the gaslight condition is something like this, where we add it to the prompt. Now, in the original design of the experiment, where we just like two conditions, either control or intervention, if we see like diagonal structure where the model is able to have good accuracy, this can align with the two interpretations, right? This is what we expect when we have like true introspection. This is also what we expect when the model just like have an ability to do anomaly detection. However, once we have this like third condition of gaslight intervention, now the predictions differ, right? So if the model is actually introspecting, we still expect this kind of like diagonal pattern. If it doesn't, we expect this kind of like something more fuzzy in the representation side. Cool. Now, what we see in practice. So we don't see something that corresponds to either of these like very clean predictions, but still there is like some interesting patterns. So if we look only on this like part of the heat map, which corresponds to the original experiment. So even on the y-axis we have the actual intervention, on the x-axis we have what the model claimed. So we find at least like one model, this like top model, Llama 70B, but has results very similar to the Claude, what Claude had in the original design, even better. So if you believe that this is actually showing introspection, so probably Llama 70B is much more introspective than the like secret internal model of Anthropic. And so you see this very nice like diagonal pattern. When we don't see an effect, so it always says control. And in the last model, we see an effect that is weaker. So like instead of like 20% in the Anthropic case, we get roughly like 10%. Okay, so we at least like we can reconstruct, we can reproduce the Anthropic experiments in 3 models. And once you add the third condition, you get something that is much more similar to the predictions that we have in the anomaly detection case. So the model now cannot really separate between the gaslight intervention and the hidden state intervention. It's kind of like mixed up. At least in this model where we did reproduce the original effect. Okay.
So how the results would look like if there was authentic?
So we would expect a diagonal pattern. Like the model should be able to detect both the control and the 2 types of intervention.
Yeah, because you asked the model.
Yeah. Yeah. So.
Yeah, I'm just looking at the results here, and it's like if it also got worse at just control and just couldn't do the task at all, versus because what I thought we would have expected is like the performance on control should have been the same, and then the other 2 should have been mixed. But here everything is mixed.
Yeah, I agree. It's really strange, but there's also like a lot of sensitivity to the wording of the prompt. So if you call the conditions differently, you can get pretty different results. It's very non-robust.
How do you know that the strength of the steering is appropriately set for each individual model? Is it possible that Llama just is closer to the Claude parameter that you may have taken, or did you what's the methodology for selecting the steering strength?
For what? Sorry.
The strength of the.
So
the
just
steering.
like tried, we use similar methodology to what they did. We verified that we find the steering strength that in a normal run actually causes the model to talk about the concept.
Can you maybe quickly re-explain how the prompting works in the gaslight condition? Is this like a system prompt that tells the model to talk about dogs, or is it like at the position where you say we're injecting thoughts here, there's a text talking about dogs?
Before the beginning of the description of the experiment.
Okay, in the system prompt.
Yeah.
Okay, thanks.
Cool. So I'm going to end very soon. So I'll briefly mention what, okay, so these are all negative results. What would be considered convincing evidence? And I'm not completely certain, but there are some criteria that would at least like be more convincing than existing ones. So we would want to have some kind of like differentiable reliability, which is a notion that people came up with in the CogSci literature. Well, the introspective report and the underlying internal states that the model reports on should be able to come apart in different ways. So, for example, you can increase one without increasing the other. This like will show that there is something second order that is different from the first order computation. You can get mechanistic evidence that there is like different circuit that is activated in different introspective tasks and not in like normal task solving, and special like failure mode. So maybe you can find cases where the model is doing perfectly the original task, but suddenly cannot introspect or cannot report its performance because of some external conditions. And there are some like initial attempts to do at least like the mechanistic part recently. So some takeaways. So privileged access is necessary, but it's not sufficient to establish an introspection, just because like every computation in transformer reads the hidden state, and in that sense, like trivially, almost like most tasks are introspective if you take privileged access to be enough. Existing paradigms admit to a simpler explanation, so we don't necessarily say that there is no introspection, but the evidence is just like not strong enough. And like extraordinary claims require extraordinary evidence. And we should probably try to get some mechanistic evidence to actually convince people that there is something unique about this introspective task. Thank you.
All right. Thank you so much. Now we have time for more questions, philosophical questions. The first one was here.
Yeah, no, sorry, I go first because I have another meeting starting in 2 minutes. But yeah, so I'm still thinking about your replication of Anthropic and your claim that with that replication, there is not the kind of introspection you want to measure. So first of all, in which layer did you steer?
So we tried different ones, and we just like chose, following Anthropic, we chose the layer where we have the strongest effect.
But like in Llama 70B, it's 80 layers, it's probably around layer.
I don't recall, but it was somewhere in the middle.
Okay, so let's say you steer at layer 30 or 40. Let's say you steer at layer 40. So I believe that from layer 40 on, so I think the only thing you can exclude with your experiment is that the introspection is not based on the layers before where you apply the steering. Because if introspection is happening at layer 20, then there will be a difference between the input, prompt, and the intervention. But if introspection happens at layer 60, then there, like your two intervention may look exactly the same.
But they don't. Like we try to measure that. You can fit a linear classifier on the representations, like separating the two.
Okay, so there is a classifier that can separate the two, but the model can't. Okay, that's a good evidence. Thank you.
Super interesting stuff. I'm going with a more philosophical one. Related to the differential reliability point. So I'm just wondering, in some sense, if introspection is even philosophically possible with a language model, and the big difference with a human is like, so we have an internal state and we have a reporting mechanism, right? So, you know, I have a stomachache, that's some internal state, and I have a means of reporting this internal state, which is like a language. In the case of a language model, the internal state is the same thing as the reporting mechanism, right? Because it's like all the internal states are to do with next token prediction. So in that sense, like you know what I mean? Any internal state is also dictating what the model says in a way.
I agree with
Yeah.
that way, that people do claim that there are like circuits that are doing something that's kind of like maybe a sub-component of producing the next token, but it can be very, you know, it can be things beyond just like deciding which the next token is, right? People show that models do represent different, like interesting latent models of the text when they process it, and they also show that they represent some like uncertainty later. So it's not very surprising if you are also like have some kind of introspective signal with this group.
If it's like if it's isolated enough, then something.
Yeah.
Yeah, thanks. Very interesting. Maybe to exclude two of the confounders that you mentioned, would you be so suppose the model would be able to report the layer at which a perturbation occurs. In that case, the gaslight prompt would not work, right?
Yeah, if it can do it, and you mean like in the anthropic stuff?
Yeah.
Yeah. So if it can do it, and if it can come back past this step where you add additional component, yeah, it will be stronger evidence. I think you would also want to show some kind of like mechanistic evidence to make sure that there is no some very simple heuristic to explain this, and also that same mechanism is applied in different introspective classes. Okay, so they design this class, maybe I can design something else that is also meant to measure introspection. I'm expecting both of them to be relying on roughly the same mechanism.
Yeah, I'm not sure I fully agree that it should be the same mechanism, but I see what you mean. And maybe the other thing to exclude another confounder, which is the semantic one. It may be the case that if you steer along the direction of dog, it will say dog. But what if you add an asemantic perturbation, like you do something in the activations that has no semantic meaning?
Yeah, so people have tried to do that. The thing is that like it's very hard to differentiate between this and like the normal ability of the model to solve in-context problems, right? So here,
yeah, I'm saying zero shot.
Yeah, models are also able to solve like zero shot in-context examples, right? When they are trained in very large scale. So I'm not sure that it's convincing enough that there is something additional here that you should like call introspection beyond like, the ability to solve that.
So thank you for the talk. We spent a lot of time talking about how it's actually notoriously hard to measure introspection in people.
Yeah.
And so it's not super clear to me that we would actually be able to measure it in an LLM even if it was happening.
Yeah.
And so you said we sort of have this impression that we introspect. And so then I ask you, what is your impression about LLMs introspecting? Because maybe it's not even something that we'll be able to measure or understand very clearly.
You asked about my question.
Yeah.
I don't think there is introspection in the strong sense what they imply.
Yeah, thanks a lot for the talk. I have a question, which is like in the original Anthropic post, they present two other lines of evidence. One of them being the model's ability to control the activation of a certain feature by saying, think about an aquarium and not think about an aquarium. And the other one is like how natural the model's own response in the past was of just like pre-filling that the model says bread, or just really like steering the model to say bread.
Yeah.
Do you think like both of these experiments could also be like compared with just adding a system prompt? Do you think that's like, yeah?
So I interpreted this experiment as kind of like validation that they do the right thing, not necessarily as the evidence for introspection. I think they also didn't like claim that this is showing introspection. They just wanted to make sure to kind of like control for confounds that explain the same behavior we observe.
Okay, thanks.
Yeah, you could just.
Thank you as well for your talk. I have a question about differentiating between control, injection, and gaslighting. You said it was quite prompt sensitive, and I just wondered whether you could comment more on that, like, because there's nothing like confidence intervals. Would you get very different results if you would replace dog by cats, or?
Oh yeah, so we don't have it here, but there is also a variance by the concept itself, mostly because of it's just like easier to steer towards some concept than to others. So for some of the concepts, you don't actually get any causal effect, or it's very hard to get a causal effect as a result of the steering. And this translates to different reportability in the model. Yeah, but it's all very non-robust in the sense that like so one thing that we noticed is that in the original Anthropic experiment, they always gave the model the same ordering of the two options, right? And if you just like switch the order, it can significantly change the results. So in all our experiments, we randomly shuffle.
Cool. Any more questions? As I said earlier, again, if you want to chat with Shauli, there's still a few slots, so you can either DM me on Slack or just come up here to the speaker and me. Yeah, with that, again, thank you. Really cool talk. Let's give it one last applause and then.
Maybe you actually test whether or not.